RFID stands for Radio Frequency Identification. It is a technology that enables not only the contactless identification of objects, but also data exchange. An RFID tag or transponder contains the current workpiece data that can be updated during the ongoing production process and accompanies the workpiece from the beginning of the production to delivery. This data could include part number, material name, etc. An RFID read-write device has access to the transponder data and forwards it to a PLC or simultaneously to a host computer. Each transponder has its own RFID number. This allows for flexible activities during the production process. Yes, even a production size of 1 is possible. RFID is one of the important enablers for smart factory. Here you see the basic components of a typical RFID system. The RFID reader sends a constant radio wave via an antenna. The tag, also called a transponder, receives this signal and responds with its own radio signal containing the information stored in its memory. The reader decodes this information and passes it on further, typically to a host computer.
In 1935, the Scottish physicist Sir Robert Alexander Watson Watt invented the radar detector. The problem was that it could only detect objects at a certain fairly short distance. It was also Watson Watt who developed in 1937 the system called Identify Friend or Foe, or in short, the IFF system. Here, a transmitter installed into a British aircraft could detect the radar signal from the ground airfield and broadcast a signal back to the base to identify the aircraft as friendly. At that time, the transponders were the size of a suitcase. Today, you see RFID almost every day, from the location chips in your dog to automated toll collection systems to Apple Pay. One reason this RFID technology, which we also use in our daily lives, is so successful is that the tags can be built very small and cheaply. But wait, each electronic device must have an energy source, and batteries are bulky, and you have to recharge them. Passive RFID transponders resolved this problem by receiving their required energy completely via an electromagnetic energy field from the RFID read-write device. Furthermore, data can also be transmitted bidirectionally via this energy field. Because energy and data are transmitted via one coil simultaneously, you need a demodulator to extract data from the energy during an upload. The new information can then be stored in the memory, which has to be, in this case, an EEPROM, as you have a read-write transponder. The encoder and modulator are active when the tag is read out. Small in size, cheap, and with an almost unlimited lifetime, these passive RFID transponders are the most commonly used. What you see from this draft is that the distance range and data transfer mainly depend on the frequency. These frequencies are fixed and the components are not interchangeable. That's also because each frequency range requires its own antenna. In general, it can be said the higher the frequency, the smaller the antenna. If RFID technology is used in logistics, for example, larger distances must be covered, sometimes up to several hundred meters. Here, so-called active transponders must be used. The transponder is normally in so-called sleep mode and is only activated by the RFID read-write unit when a data transfer is to take place. This can increase the service life of the transponder's battery up to several years. Advantages are, for example, increased range, lower signal runtime, higher data transfer, and the option to read several tags at one time. But on the other hand, the tags are large, costly, and have a limited lifespan due to their battery. The last type of RFID tags are the so-called semi-active tags. As the name suggests, this device incorporates some active RFID features, such as a battery to provide power for its memory and passive RFID features for data transmission purposes. These tags have a longer lifespan than active tags and are less costly. How can passive tags with a low-powered chip transmit data? One possibility is the so-called backscatter modulation. The principle is simple. The coils of the read-write device and the tag are coupled via a magnetic field. When one of those coils are shorted, it changes the inductance of the other coil. Watch the switch of the tag. Switch open stands for the binary information 0. Switch closes, and we have binary data 1. However, the change of the signal is very small, very susceptible for noise, and useful for small distances. One option would be frequency shift keying. To transmit a binary information, two discrete frequencies are used. As you see, the space frequency represents logic 0 and the mark frequency logic 1. In phase shift keying, the phase position is switched between 0 degrees and 180 degrees, as we see here.
Now you have a much better idea of how this technology works. Of course, RFIDs are used more and more in our daily lives. But with all its possibilities and benefits, there are also risks. But that information will be discussed in another video. For more information about RFID and sensors in general, please go to our webpage. If you want to be updated about future new videos, please subscribe to our channel.